Hello sir, my name is Rishi and I am going to talk about the automata theory in networking. Here we can see the application of automata theory in networking. Next, what is an automata? In simple words, an automata is any system which works by itself without any human interference. An introduction to automata theory is nothing but it is a theoretical branch of computer science and mathematics. It's the study of abstract machines and the computation problems that can be solved using these machines. The abstract machine is called the automation. An automation with a finite number of states is called infinite automation. Next, we can see the types of automata here. First, there are two types of automatas, finite and infinite automata. Infinite, and again we have two automatas, deterministic finite automata and non-deterministic finite automata, DFA and NFA. And in infinite automata, we have Pushton automata. Now we are going to see the cycle of conversion. First, the regular expression to the language to the LNFA and then NFA to DFA. Applications of automata theory. Each model in automata theory plays important roles in several applied areas. Finite automata are used in text processing, compilers, and hardware design. And contextual grammar are used in programming language and artificial intelligence. Originally, CFGs were used in the study of human languages. Cellular automata were used in the biology and the most common. Next, we are going to talk about the applications of automata theory in networking. Until now, we have discussed various fields in which the automata theory is used. Now, we are going to discuss in specific how the automata theory is used in networking and communication. Networks use some specific protocols to transmit and receive the data. That protocols are error control, flow control, bandwidth limitation, etc. Next, we are going to solve these problems. It requires a definition of one or more communication protocols that are shared conventions for the transmission of data in one direction and acknowledgements in the other. Rather than attempting to describe all the required functionality as a single protocol, it is now common practice to provide a protocol stack. Protocols at layer and n of the stack make use of the functionality provided at layers and below. For example, the Internet protocol stack have 5 layers. First one is application layer, second one is transport layer, third one is network layer, fourth one is link layer, and the final one is physical layer. Now, a very basic protocol used in transmitting. In this diagram, the horizontal lines show the time and the center sends some data and it is received by the receiver. And we can see that here the sender sends the data from the receiver got the data. And now, how can we apply automata in this protocol? And now in the next step, we are going to discuss about that. Here we can see finite state models of the sender and the receiver using this protocol are very simple. In construction, these models we assume that there is a higher level process on one side that invokes the sender when it has a data to send and a higher level process on the other side that will be notified by the receiver whenever data have arrived. Although we won't handle this part of the process in the models we are about to build, we can note that sender will maintain FIFO, I mean first in first out of message that has been told to send. DFA for the given problem. Now we are going to discuss about the DFA for the given problem. In writing our finite state models, we will use to correspond to the sending of a message and correspond to the receiving of one. We'll use D to correspond to a message containing data. And the next we are talking about the receiver. The sender waits until it is given data to send. At that point, he changes state. sends a data message, and then returns to the waiting stage. The receiver waits until the data arrives. When that happens, it makes in which it delivers the data. When it is finishes, it returns to its state. Next, we are going to talk about the application in stop and wait protocol. Another widely used protocol in the networking stop and wait protocol, as also known as the automatic repeat request, known as NARQ. In NARQ protocol, the receiver communicates back to the sender, and the sender explains the communication to help it determine when a failure has occurred, and a message should be transmitted. A simple subfamily of ARQ protocols is called stop and wait. Next, DFA for the given application. Yeah, the sender first we'll talk about the sender here. The sender will never send a second message until it knows that the receiver has successfully delivered the data from the first one, and it solves one error control problem. If a data message is lost, the sender will retransmit it after it times out waiting for an ASIK. If a data message is corrupted, and the receiver can tell that the receiver can simply fail to send an ACK. The sender will time out and the message will be resent. There are also variants of the stop and wait protocol in which explicit native ACK messages are sent when a message is corrupted. Next, we are going to talk about the application in alternating bit protocol. The alternating bit protocol doesn't add arbitrary subscripts. It does, however, add a single control bit to each data message and to each ACK. The bit will alternate values with each transmission. By convention, the receiver will flip the bit up before sending an ACK. So, the message that acknowledges the receipt of DO D not will be ACK1 and vice versa. And now we can see the diagrams of the sender and the receiver. First, the time clock, the need ACK, and we can see the active waiting and activating and mini ACK and timeout. Next, we'll talk about the alternating bit protocol. Describe the beware of alternating senders that exploit this new protocol requires two copies of each states that were needed for the stop and wait protocol. One copy corresponds to handling data whose control bit is 0, and the other to handling data whose control bit is 1. Here, the both sender and receiver are initially in waiting stage. Until now, we have discussed so many things regarding the applications of automata in networking, and we have seen so many examples and so many diagrams. Uh, Thank you for giving me such opportunity to take my presentation. I hope I have given a good presentation. Thank you, sir. And next PPT is for you, sir. Thank you for giving me this opportunity. Thank you very much.